Hi, and welcome to section 2 of this course, where we're going to take a look at the basics of computer vision and OpenCV. So I will just briefly go over the topics we're covering in this section. So firstly, we're going to take a look at what exactly are images and how are they formed. After that, we're going to look at how images are stored on computers. And then after we complete that, we're actually going to get started into OpenCV and do some basic operations such as reading, writing, and displaying images, then performing grayscale operations, then taking a look at the different color spaces that we have available, and also representing images in histogram form and how you interpret that. And lastly, we're going to use OpenCV to draw some basic shapes and put text on images. Hi, so what exactly are images? Now I have a one-line definition here for images, which tells us that images are two-dimensional representation of the visible light spectrum. So what exactly does that mean? What does two-dimensional mean in this context? Now, you may have a faint idea that an image can be a photograph, can be something you see on your laptop screen or TV screen, and that's exactly right. Those are all two-dimensional planes, where there's only an XY dimension. And that XY dimension here corresponds to different pixel points on computer screens, or in photographs, basically dots per inch, DPI. You may have heard that in some other form, printers perhaps. And so now, each pixel or DPI point reflects different wavelengths of light, and that is where we refer to the visible light spectrum. Now, the visible light spectrum is part of the electromagnetic spectrum, which consists of radio waves all the way to gamma rays. And different waves here have different wavelengths. And the visible part, well, we say visible because it's visible to our eyes, consists of different wavelengths, and each wavelength corresponds to different colors, all the way from red, green to blue, and slightly purple. So now in an image like this is Van Gogh's Starry Night painting. Each point corresponds to a different color, which means it reflects different wavelengths of light, which is what we see in these images. So now I hope you have a faint idea, or at least an idea of what images are.